Okay, 11 is maximizing the area. A rancher wants to enclose 2 rectangular areas near a river, one for sheep and one for cattle. There are 240 yards of fencing available. What is the largest total area that can be enclosed? All right, now for this one, because we have a river, we don't need any fencing along the river. So 2 rectangles like that, okay? And we're told that we have 240 yards of fencing. So, the largest total area that can be enclosed, so we want A max. Okay, well, area is equal to length times width, right, of that whole big rectangle. So L times W. That'll give me that area, right?
Do we have to account for the fencing that's going through the middle? Yeah.
Mm-hmm.
Okay, I didn't know.
Yep. Yeah, so that's going to be part of the 240. So we're going to say that what? What does 240 get me? 240 gets me 1L and 3W. Yeah, so 3 W's. Okay, so I'm just going to solve for L here. So 240 minus 3W equals L. Right, I just got to get one of those letters by itself. Then I'll take this and plug it in for that L. You can use X's and Y's, you can use whatever letters you want. So my area then is going to equal 240, take away 3W, times W again. Let's clean that up. 240W minus 3W squared. So now that's my formula in terms of one variable. Is that okay with everybody? Are you following along with me? If you got any questions, or you need me to slow down or anything, please ask.
Can you just slow it down just a little bit?
Sure. What are you, okay? Are you following, or are you just trying to keep up?
I'm just trying to keep up.
Okay. Are you up to where I am now? Okay. So what's the next step? Oh, sorry, go ahead.
How, like, when we're just doing something with, like nothing through the middle, like just a regular square, and it's length times width, is it, like, why are we doing 3W? I know it's because there's 3 there, but isn't it normally just length times width when it's just a square?
Correct, and area is always length times width when it's a rectangle, okay? But what we're doing is that's 2 variables, and we can't do the derivative when it's L and W. It has to be all L's or all W's, okay? So they gave us this other piece of information. They told me that all of the fencing adds up to 240 yards. So this is going to be my substitute equation. So 240 has to equal this piece plus this piece plus this piece plus this piece.
Okay.
Okay, so that's what allows me then to get my substitution in.
All right, yeah, I was trying to include I was thinking another length.
Yeah, normally you would have one, but because they said they did it on the river, if you look in the picture in the book, there's no fence along the river.
In that case, would it be 2L plus 3W?
Yeah, if it was just a normal fence out in the middle of the field somewhere, then yes, you'd have 2 L's and 3 W's.
That's what I was doing wrong.
Okay. Alright, so then we do our substitution, and now we're here. So we've got one equation and one variable, so now it's time to take the derivative with respect to W. So what's the derivative of 240W? 240. And the derivative of negative 3W squared? Negative 6W, right? Okay. And then what do we do with the derivative once we have it? Well, we gotta do something first. Set it equal to 0, right? So we can solve it, okay? So in this case, I'm just gonna go ahead and move the 6W over. And then if I divide, W is 40. Once W is 40, I can go back and plug it in to figure out what L is then, right? So L is going to equal 240 minus 3 times 40, which equals 120. So my dimensions are going to be 40 yards by 120 yards. Those are my dimensions. And for number...
Area?
Pardon?
Doesn't it want the area?
Oh, okay, it says
4,800.
what is the largest total area?
4,800
Yes, so you would just multiply these together.
48,000.
or
So 40 times 120 is 4,800 square